Today, we're going to talk about the invisible network that basically powers our entire mobile world, LTE. Seriously, it's the reason you can stream, scroll, and connect from pretty much anywhere, and we're going to dive into exactly how it all works.
Oh man, just think back for a second. Back to the mid-2000s. You probably just got your first smartphone. It felt like magic, right? But then you tried to watch a video or even just load a web page, and it felt like it took forever. That little spinning wheel, that was the universal sign of frustration.
And, the problem was pretty simple. Our phones were getting way smarter, but the networks they were running on just couldn't hang. 3G was amazing for its time, don't get me wrong, but it just wasn't built for the super data-hungry world that smartphones were starting to create.
This created this huge gap between what we wanted our phones to do and what they could actually do. So yeah, welcome to what I like to call the age of buffering.
And this gap, it was massive. On one side, you had 3G, which was just struggling with slow speeds, and it was handling voice calls using this old-school system called circuit switching. Think of it like having a separate dedicated phone line just for your voice, totally separate from your data. But on the other side, well, that was us. We wanted everything, and we wanted it now. HD video, online gaming with no lag, powerful apps that lived in the cloud. The network itself was the bottleneck.
So, closing that gap wasn't going to happen with a simple upgrade. Nope. It needed a complete evolution. And that evolution, well, it was called LTE. So what is LTE really? The name kind of says it all, long-term evolution. It was designed by this group called the 3GPP to be the next huge leap forward. And the main goals were simple. Make it fast, make it responsive, and move everything, your voice, your videos, all your data, onto a single, super efficient network that speaks just one language, the language of the internet.
So what was on the big wish list for this new network? Well, first off, we obviously needed way higher data rates for things like video and cloud apps. Just as important, though, was low latency, that responsiveness for real-time stuff. We needed a network that could keep you connected even if you're flying down the highway in a car, and, this is a big one, a single global standard, so our phones would actually work everywhere. LTE was designed to check every single one of those boxes.
So, how in the world did they pull all that off? Let's peel back the layers a bit and take a look at the core architecture that makes all this magic happen.
Okay, I know. At first glance, this looks a little complicated, but the entire LTE system really just boils down to three main parts. Let's start on the left and kind of work our way through it. First up is the user equipment, or UE for short. This is the easy one. It's just the device in your hand, your phone, your tablet, whatever. It's the starting point for everything. Simple enough, right?
Next, your phone has to talk to something, and it connects wirelessly to the EU-TRAN. Just think of this as the radio part of the network. It's all the cell towers you see everywhere. In the world of LTE, they have a fancy name, eNode Bs. They handle all the radio signals back and forth.
And finally, all those cell towers connect to the Evolved Packet Core, or the EPC. This is the real brain of the entire operation. It's the central command center where all the management, the routing, and the connection to the big wide internet happens.
Now, inside that brain, there are four key players running the show. First, you've got the MME, which is kind of like the network's traffic cop. It checks who you are and keeps track of where you are. Then there's the SGW, which is like a local router that just moves your data around inside the carrier's network. Next, the PGW acts as the main gateway, which is your phone's on-ramp to the actual internet. And finally, you have the PCRF, the rule maker. It enforces your data plan and makes sure your important video call gets priority over some background app update.
Okay, so that's the technical how. It's a bit nerdy, I know, but what about the so what? With this brand new architecture in place, what actually changed for us in the real world?
The first and maybe biggest revolution was latency. That's the tiny delay between when you tap on something and when you get a response. LTE slashed it to less than 10 milliseconds. I mean, that is literally faster than the blink of an eye. It was an absolute game changer. And that tiny number, well, it changed everything. It's what made smooth, high-quality video calls over LTE, what we call VoLTE, even possible. It meant you could actually play a real-time online game on your phone without it being a laggy disaster. It made cloud apps feel instant, and it laid the essential groundwork for all the future tech we're seeing now, like AR and VR.
And the second revolution? Just raw, unfiltered speed. With theoretical peaks of 300 megabits per second, LTE wasn't just a little bit faster than 3G, it was in a completely different universe.
This incredible speed is what truly untethered us. This is why you can stream Netflix in HD on the bus. It's why you can download a huge app in seconds instead of minutes. It turned your phone into a reliable hotspot for your laptop, and really, it fueled the entire app-based economy that we all pretty much live in today.
So when you put it all together, the legacy of LTE is so much more than just faster internet. It's about a fundamental shift in what a mobile network can even be.
It really just comes down to this. LTE completely revolutionized mobile broadband. It delivered on all three of its key promises: incredible speed, super low latency, and a modern, internet-based network for absolutely everything.
But here's the kicker. LTE didn't just fix the problems of the 3G era. By creating that efficient all-IP architecture, it actually built the very foundation that 5G is standing on today. It was the necessary evolution that made the next revolution possible.
Which, leaves us with a really fascinating question. We know the world that LTE built. It's a world of on-demand video, constant connection, and these incredibly powerful mobile apps. So what completely new world, what things we can't even imagine yet, will be built by its successors?